This time our task is to merge two sorted arrays, and this is an easier version of implementing whole or full version of merge sort. And since there are various sorting algorithms and merge sort is one of the more popular, and you should of course also be able to implement it from scratch, but this time we are doing an easier version. And of course there is a whole class of simple problems where, for example, more advanced problem would require you to merge k-sorted arrays, or maybe some other data structure like linked lists, since there are also similar problems regarding linked lists and so on. And so now we are dealing with one of the easier cases, and here is the description. Given two sorted arrays called array1 and array2, merge them into a single sorted array. Yes, of course, merging is not a problem, but we want to preserve order. And there are a lot of ways in which we can implement it in C++, and I will try to show you a couple of them. And we will also, as always, discuss various pros and cons. So which one is more efficient, which one should you use in real life, and so on. So that's the problem for today. And the merged array replaces the contents of array1. So there's an additional constraint that we should not return like a newly allocated array. We should simply replace the contents of array1 and expand it to also accommodate array2, like all the elements from the array2, but we will use the original place in memory that was occupied by array1. And here is an example. Let's say that we have following arrays 1, 3, and 5. That's our first array, so it's already sorted, and that's the constraint. And the second array is also sorted 2, 4, and 6, and of course together they will form a following array 1, 2, 3, 4, 5, and 6. And that's the output array. So we will try to do it using 3 different methods. And the first one, as always, will be the least efficient, but it's something that people do, and we'll discuss why it's not efficient. Then we'll try to use like merge implementation from scratch without using any advanced C++ features. And finally, we'll use some more advanced C++ features in the third implementation. And the third and the second implementation both are similarly complex when it comes to the time complexity. So the efficiency is not really different, but there will be a big difference when it comes to the implementation, depending on how much advantage we are taking of the C++ itself. And then we have some test cases, and everything below those 3 cases or those 3 functions that we'll fill in a second are just tests and helper functions. So at the end, just a lot of helper functions will test on the following cases. So the first one is the one that we discussed. Then we will have some little bit mixed. So for example, all before or all after, all equal. First array is empty, second array is empty, there is a single element in each array, there are also negative, there are duplicates, and so on. And so all kinds of cases, as well as some randomized checks in addition. So here we have some randomized checks. So besides the ones that are hard-coded, we will also each time try to test it on some randomized input. So first, let's do the simplest and the least efficient implementation. Where we simply insert to the first array at the very end. So at the end of the first array, we insert the second array like this. And of course, at this point, it's not sorted. So what can we do? We can simply use std sort. And using the iterators, and here I see that I forgot to close the parentheses. Like this. So it's least efficient. We are just inserting first. They are all in the first array after the insertion, but they are not yet sorted. And then we resort starting from scratch. So we are not taking advantage of the situation where both input arrays are already sorted. That's why this second operation is n log n. Yeah, but the size of the first array is unknown and the size of the second array is unknown, or they can be different. So that's why we don't call it n log n, we call it n plus m. Yeah, so or maybe we can introduce another variable called k, which will be the size of those two arrays together. Yeah, so in that case it could be also called k log k. And now let's compile. And in the case of the first implementation, everything passes. Yeah, but of course, it's not efficient enough. So now we can try to implement this merging from scratch. We will put the size of the first array in variable n, the size of the second array in variable m, and then create a new variable called k and make it store the sum n plus m. So the sum of both lengths. And now we will resize the first array to accommodate enough space to have space for k elements. And now while m, which is the size of the second array, we will use both m and n as our indices. So we will try to resort it, or not resort it, we will be inserting everything again to the first array from both the second and the first, without any additional sorting, as we will insert it preserving the order, and we will use both variables as our indices. So we'll start from the end and move towards the start. And while m is greater than 0, we will here check if n is greater than 0 and the current position, or the element on the current position in array 1, so n minus 1, is greater than or equal to the current element in array 2, which is on position m minus 1. If it's the case, then we put to array 1, we're starting from k minus 1, so on minus minus k, starting from the end, we simply switch the positions in the same array. So we take the element from minus minus n. Otherwise, we take it from the second array. And thus, we can preserve the order. From the second array, like this. And now we can save and try to recompile. And everything works also for the second case. So now the most advanced when it comes to usage of C++, we will create a second or the third array, but we will not use it outside of the function. And so it will be only used inside, allocated on the stack. And it will not outlive the function call. So we can call it temp Then, of course, for the temp, we have to resize it to also accommodate k elements. And not comma, but plus. Yeah. And now we can use std merge. There is already such a functionality. And we put here array1 from the start till the end, as well as array2 from the start till the end. Sorry, here. And as well. And there is std back inserter, which will put it where? Into our TMP. And by the end, we will move it to the first array. And sorry, I see that it's called A and B instead of array 1 and 2. So let's just keep one notation. And here we'll move out to where? To array 1. Now let's recompile. Sorry, not out. It was called TMP. Let's recompile. And something failed. The third case. Let me recheck. And of course, I made a mistake here, where we should only reserve instead of resize. Yeah, so reserve changes the capacity, how much space is reserved for our vector, and resize changes the size, so how many elements are already used. And in this example, if we did, as we did before, resize, then we put k elements already, so size 1 plus size 2. And then to those k elements, we added another k elements, essentially having twice as big vector using the back inserter. So let's compile, and now everything should be okay. And all tests passed successfully.